Good afternoon. We are going to take notes on section 4.4, angle side angle and angle side congruence criterion. Okay, so basic strategy for angle side angle application is you're going to prove the triangles are congruent, and we'll do that using any method you've got. Side, 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 angle, angle. And we also have an angle, side now that we can add on to this. After you've proved the triangles are congruent, then you're going to use corresponding parts of congruent triangles are congruent. In other words, CPCTC, you'll use that to prove any corresponding parts that you need are going to be congruent. All right, we're going to do an example, and it's in a 2-column proof. It says a technician installs cables from a cell tower to the ground. So there's your cables. To pass inspection, both cables must be the same length. Does this installation meet the cable length requirements? Explain. Okay, so we are trying to prove that the cable lengths are the same. So we're trying to prove that the cable on the left, BA, is congruent to the cable on the right, BC. So to do that, we need to prove the triangles are congruent. And so we know that these are 52 degrees. That's given in the drawing. This cell tower is perpendicular. So we can say that BD is perpendicular to AD. That's given in the drawing. What's not given in the drawing is the fact that these two angles are congruent. That has to be given. And reflexive property will be used. At that point, we have an angle side and an angle. And we can go from there. Okay, so let's do this. Angle ABD is 52 degrees. Angle CBD is 52 degrees. And BD is perpendicular to AC. That's given, and we would say given in the diagram. It wasn't listed as a given, it was given in the diagram. Okay, so we know that this is perpendicular, so we can say that angle A, oh actually let's do the 52s. Those are the same measure, so we can say ABD is congruent to angle CBD by the definition of congruent angles, which says their measures are the same. Since those are both 52, we can say that they are congruent by the definition. Okay, so we know this is perpendicular, but we have to actually say that that means 90. So the measure of angle BDA equals 90 degrees, use a semicolon. The measure of angle BDC is also 90 degrees. And that is the definition of perpendicular lines, is that they meet at 90 degrees. Now that we've said they're both 90, we can say they're congruent. Angle BDA is congruent to angle BDC because of the definition of congruent angles. Okay, so we've got these two angles, we've got these two angles. Now we need that side. So we're going to say that side BD is congruent to side BD because of reflexive property of congruence. Now we've got our triangles. We can say triangle ABD, the left one, is congruent to triangle CBD because of angle side angle. Now that the triangles are congruent, I get their body parts. I can now say that cable AB is congruent to cable CB because corresponding parts of congruent triangles are congruent. So take a moment to look at this and see how the logic goes. You have to state the measures, and then you can say they're congruent by the definition. In the case of perpendicular, you have to first say that the definition of perpendicular means they are 90, so we stated the measures. Then we could say that they are congruent by the definition. So you always have to get the measures first, and then you can say they're congruent by the definition of congruent angles. All right, flip the page. All right, here's our new one. Angle, angle, side, triangle congruence theorem. It says if two angles and a non-included, that's a new word, non-included, so not in between them, a non-included side of one triangle are congruent, and two angles and a non-included side of another triangle, then the two triangles are congruent. Okay, so let's label what they tell us here. A and D are congruent. Okay, so A and D. B and E are congruent. So B and E. Now here's where this is different from angle, side, angle. BC is a non-included side, and BC and EF are congruent. See how it goes? Angle, angle, side. So using this postulate, or sorry, theorem, we can say triangle ABC is congruent to triangle DEF by the reason of angle, angle, side. Now, we've had a lot of different congruency theorems. One of them that we have not had is angle, side, side. For obvious reasons, you can tell this one does not belong. There is no angle, side, side. Pretty easy to remember. Okay, let's go to example 1. Find the value of x, justify your answer. Okay, so I have a 65-degree angle that matches, a 75-degree angle that matches, and a 10-centimeter side that is not in between the angles. So from that, I can say angle C is congruent to angle Z, 65, 65. Angle A is congruent to angle Y, 75 and 75. And now the non-included side, AB is congruent to YX. So that gives me two angles and a non-included side. So angle, angle, side tells us that the triangles are congruent. We're justifying our answer. You first have to prove that they're congruent. Now we can use that fact to find the value of x. So now, because of corresponding parts of congruent triangles are congruent, I can say that x plus 3 is equal to 2x plus 4. That is my justification. Now let's solve. I'm going to solve with x on the right, so I'm going to subtract x to the right, subtract 4 to the left. Negative 1 equals x, except that this is 13. 13 minus 4, excuse me, is 9. That's better. So x equals 9. And this is our justification. We proved the triangle's congruent and then used corresponding parts. That is justified. Okay, example 2. Which postulate or theorem can you use to prove that triangle ABC is congruent to triangle HJK? Okay, so let's see what we've got. We have a side and a side. We have 90-degree angles. Those will match up. And we have another angle, A and H. So we have an angle, and a non-included side. That would be why they are congruent to each other. Okay, last one, example 3. Is it possible to prove that the triangles are congruent? If so, state the postulate or theorem you would use. Okay, so we have an angle, and a non-included side. So that would be angle, angle, side. On this one, we have a side, and a non-included angle. There is no side angle. So these are not congruent. And again, ASS is not one of our theorems or postulates. Okay, on this one we have an angle and an angle, But reflexive property says that their shared side, which is in between the angles, will be congruent. So it's an angle, an included side, and an angle. Angle, side, angle. All right, that's everything for today. Have a great afternoon.